Okay guys, so today we had a lesson on implicit differentiation. It's not easy. It's kind of difficult until you get the hang of it, and there is confusion until it starts to make sense. Let me go over very quickly with you some of the basic concepts. First off, the derivative of x squared in terms of x is 2x. The derivative of y squared in terms of dy is 2y. The derivative of y squared in terms of dx is the problem. When the variables are the same, we just differentiate. It's not a big deal. When the variables are different, we run into a bit of a problem. So what we're going to do is we're going to use the power chain rule to help us. Now what the power chain rule says is to do the derivative of the outside. Take the derivative of what's ever inside the y and forget about it and just bring the 2 down and take 1 away. And then do the derivative of the inside. And that looks like this. So we're going to take the derivative of the y squared, the derivative of the outside, and then we're going to multiply it by whatever the derivative is of y in terms of x, leaving us with 2y times dy by dx. And without knowing what y is in terms of x, we're stuck there. We can't go any farther. So let's take another example that I looked at in class. Consider the derivative of 2x cubed plus 1 by dx. Well, when you take the derivative, let's make it a little bit more interesting, to the 3. When we take the derivative of this, we know that we're using the power chain rule. And what happens is we take the derivative of the outside, and that becomes 2x cubed plus 1 squared. That's the derivative of the outside. And then we multiply it by the derivative of the inside, which is 6x squared. If I wanted to show what was happening here, your derivative of the outside was actually and the derivative of the inside was, so this whole derivative simply became 2x3 plus 1 squared. So that's the derivative in terms of the entire polynomial. And then this one simply became 6x squared. Okay, so there's how it works. Let's take a look at one other thing that I did with you in class that I think made a little bit of sense for you. So I'm going to try it one more time so that you can see it again. Let's say we know that y is equal to 2x3 plus 1. And let's say someone asked you to come up with the derivative of y squared in terms of x. Well, if we don't know what y is, if we pretend that we don't know at all what y is, we know that we take the derivative of the entire thing, which is dy squared in terms of y, times the derivative of the inside in terms of dx. And this would become 2y dy by dx, saying no matter what y is, the derivative of y in terms of x, or the derivative of y squared, in terms of x, will be 2y times the derivative of the inside. Now, let's say that we happen to know what y is. So instead of writing this, you would write now remember, what we know is we know that y equals 2x cubed plus 1. So taking the derivative, it would be 2x cubed plus 1 to the 1, that's the derivative of the outside, times the derivative of the inside, which gives you 12x squared, 2x cubed plus 1. That would be the answer. Let's compare that to the answer that we got up here when we didn't know what y was. If all of a sudden we now know that this is our answer, no matter what y is, and if someone was to come along and say, okay, well y is actually equal to that, then we can put that in for y. The derivative of y in terms of x is simply going to be, so this is going to be 2x cubed plus 1, 6x squared, 12x squared, 2x cubed plus 1. And you'll notice that this answer here and this answer here, oh, can't see, I'm sorry, this answer here and this answer here are the same. And remember that this answer came from doing it implicitly. Okay, that being done, that's our short introduction. I'm going to stop there and then I'll run through the examples in different videos.